comprehension. So what is the given information? Length of the string he given is tied to a ball and other end is connected to a fixed point. Here O is fixed point. The ball is released from rest with string horizontal and just start. Take some line as a reference line. So then ball is at A. So energy associated with the ball is potential energy only. Initially at rest, there is no kinetic energy. When this is total energy of the ball at A. When it reaches C, at this point, potential energy is zero. It has only kinetic energy. Velocity attained by the ball is Vc square. So mgh equal to half mvc square. Vc square is 2g. Here h is nothing but length of the string. So now another point is when is at ball reaches the point C. So at what height position of the ball with respect to the reference level? So it is theta. It is 90 minus theta. Here this one is L. It is OP is L sin theta. So at B, so the potential energy is mg. This mg into L minus L sin theta. This one is L minus L sin theta. Plus it has some kinetic energy. It attains some velocity, which is equal to half into, I can say, potential and total energy at B is same as total energy at A. So now half mvb square, which is equal to mgl get cancelled, mgl sin theta. So I can say vb square is 2gl sin theta. Say it is 1. Say it is 2. Now he said vc square is 4 times from given information. vc square is 2gl. Vb square is 2gl sin theta. So sin theta here is 1 by 4. Theta is sin inverse. So second option. Here Vc square, squaring both sides, Vb square plus 2Vc Vb, sorry, minus, right, cos alpha, it is equal to Vb square. Alpha is angle between Vc and Vb. Here it is at this point. If you draw a tangent, it gives so direction of velocity at B and at A. This. So here angle is 90 degrees. This one also 90. So 180 plus theta. This angle will be 180 minus theta. So 90. So 180 minus theta. Now here I can write Vc square minus 2Vc Vb cos alpha here is 180 minus theta. So Vc square is 2 times VCVB angle between, sorry, VC and VB, right? It is VC and VA. Extending VC and VB. So this angle here it is 90 minus theta. This is 90. Here it will be, sorry, not this angle. What we have to find out is this angle. That VC direction is this. So it is 90 minus theta. It will be theta. You get theta, right? Sum of three angles. It will be theta. This angle will be 90 minus theta. So here it is 90 minus theta, which is here. VC will be sin theta. You get here. So VC equal to 2VB. So the VC, we know it, root of 2GR squaring both sides. We get the VC square is 4VB square sin square theta. VC square is 2GL VB square 2GL sin theta into sin theta. So here sin square theta, here if you square it, you get sin cube theta is 1 by 4. Sin theta will be 1 by 4 power 1 by 3. So B is the answer. The radioactive substance disintegrate according to the disintegration law. So dN by root n, which is minus lambda dt. Lambda is decay constant. N is number of active nuclei at any time. Initially is N0. Half-life means initially number of nuclei is N0. Half-life means number of nuclei becomes half dN by root n, which is equal to time taken to become half of the nuclei is T half, which is dt. So which implies 2 root n, n0 to n0 by 2 minus lambda T half. So 2 times root n0 by 2 minus root n0, which is lambda value is root 2 minus 1.4 minus 1 is 0.4 T half. So here if you take root n0 common, 1 by root 2 minus 1 is root 2 minus 1. Minus is there here. Minus root 2 minus 1 T half. So 2 root n0 1 minus root 2 by root 2, which is minus of root 2 minus 1 T half. This get cancelled. T half will be root of 2 n0. So B is the answer. Active nuclei at any time. Integral dn by root n at any initially n0 at any time. We don't know how many nuclei. Lambda dt at any time initially times 0, which is 2 root n between n naught and n, which is minus lambda t. From here, root n minus root n naught is minus lambda t by 2. Root n is root n naught minus lambda t by 2. Then times 0, root n is root n naught. Number of nuclei will be not everywhere in the graph same thing. So for t is equal to n naught by t equal to n root n naught by 2 root n naught by lambda, then root n becomes number of nuclei becomes 0. So here, and the nature of graph cannot be straight line. Here, squaring this, you get n naught square plus lambda square t square by 2 minus lambda root n t. So here, n is n naught. So n you take along the y-axis, t along x-axis, you have lambda root n. So x square coefficient is positive and it is of the format ax square plus bx plus c. Option C and option D are not correct. So it cannot be concave of. So option B, but it should touch somewhere. So for a spherical refracting surface separating two media, U and V are object and image distances. So given some introduction here, refraction at curved surfaces. When object is placed at O, so ray entering from rarer to denser, then what we have formula is mu2 by V minus mu1 by U is equal to mu2 minus mu1 by naught. Here distances are measured from this point. So that is mu2 already we know it, 3 by 2 V minus mu1 is 1, U is minus 10, 3 by 2 minus 1. So the radius of curvature is 20. So here you have 1 by 40, 3 by 2V, which is equal to 1 by 40 minus 1 by 10. You get here 1 minus 4. So from here what you can say is 2V will be minus 40. That means here image is minus indicates image is formed at 20 centimeters to the left of P. Here a point object O is at a distance lie at a distance 20 centimeters from P in front of a solid glass of sphere of radius. So now object is placed which is at a distance of 20 centimeters with respect to this refracting surface. So here it is refractive index of air 1, glass refractive index 3 by 2. Same like earlier, mu 2, that is 3 by 2V minus mu 1 minus 20 equal to 3 by 2 minus 1 by 2, or R here is 10 centimeters. So 1 by 3 by 2 minus 1 by R. So we get here 1 by 20. That means 3 by 2b plus 1 by 20 here is this. So we get here 3 by 2b is 0. So b here is infinity. So here after second surface, again here from glass media to denser medium to rarer medium, here it is, here mu is 1. So 1 by v minus 3 by 2, object is at infinity, 1 minus 3 by 2 by r, so that is minus 10. So 1 by v minus 0 equal to minus 20. That means v here is 20 centimeter, the distance of 20 centimeters of right of P2. Here in figure, the voltage drop across resistor, which is equal to 40 volts, across inductor 40 volts, across capacitor potential drop is 10 volts. So these are all RMS voltages, not peak voltages. Here effective voltage, applied voltage, effective applied voltage V equal to VL minus VC whole square plus VR square. That is VL minus VC is 30 square, 40 minus 10. We get 50. So here VRMS, we got it as 50, and peak voltage is root 2 into VRMS, that is 50 root 2. Option B is correct. And here the peak value of current, so potential drop across resistor is 40 volts, resistor is 4 ohms, IRMS will be potential drop by this 10 amperes, peak voltage will be 10 root 2 amperes. So the value of inductance, so here potential drop across inductor is IXL. So current is 10 amperes, XL is omega L, potential drop here is 40 equal to 10, here omega is 100 pi of L. So here it is 10 4 times, L will be 1 by 25 pi Henry. So next potential drop across V will be IXC. Capacitive reactance, VC here is 10, I is RMS current, XC will be 1 by omega C. C will be 1 by omega. Omega is 100 pi. So all four options are correct. Here magnitude of electric field. Here both are equilateral triangle. Two equilateral triangles ACE and BDF has a common center O and is taken symmetrically in the plane. 6-point charges are placed at the vertices. Magnitude of the net electric field at O. Here they are symmetrically placed. So this distance is given it as L. Even this distance is L, this distance L. So electric field at O is electric field at O due to the charge present at E. Electric field at O due to the charge present at B. Electric field at O due to the charge present at D. Electric field at O due to the charge present at C. Electric field at O due to the charge present at F. And electric field at O due to the charge present at F. Here, so at O we assume unit positive charge. Electric field at O due to the charge present at E is equal to KQ by L square. Towards right. Electric field at O due to the charge present. That is also KQ by L square in the same direction here. Right. Here positive charge, here it is negative charge. It will be positive charge will be attracted towards it. That means, so electric field at OE plus electric field at OB are in the same direction, which is 2 times KQ by L square. Similarly, it's along which direction? EB direction. Electric field at O due to the charge present at F. Electric field at O due to the charge present at E is also 2KQ by L square along CF. So one is along this, other is along this. So resultant of all this will be, say, E1 here E2. E1 plus E2 will be, here it is equilateral, it is 60 degrees, it is 120 degrees. So the resultant will be root of E1 square plus E2 square, 2E1 E2 cos 120. E1 and E2 magnitude wise they are same. E square plus E square plus 2E square cos 120. This get cancelled. E or E1. Because, right. Now, I found out electric field due to 4 different charges and electric field at O at due to charge present at A, and that is towards upward direction. Electric field at O due to the charge present at D is here plus, that is also in the upward direction, which is 2 times KQ by L square. Now here E direction is along dA. It is also along dA. So now net electric field at center is 2kq by L square plus, because both are in the same direction, that is 4kq by L square. K here you know that 1 by 4 pi epsilon naught q by L square. Q by pi epsilon naught L square. So first option is correct. So option B, potential at O will be potential at O due to A plus potential at O due to B, potential at O. C, potential at O, A, B, A, C, D, F. And E also, right? That is nothing but K potential, K into minus Q by L OB, and that is it's a scalar, so nothing to do with the direction. K into Q by L OB. OC is plus Q by L, then OD plus Q by L plus then OE. OF will be minus KQ by L. OF is KQ by OE is KQ by L. So minus KQ plus KQ minus KQ, this all get cancelled out. Second option also correct. And here about third and potential energies, electrostatic potential energy at B and E. So here no space. Okay, I'll use this space right now. That is electrostatic potential energy Q at B will be potential energy due to the charge present at A plus UB at C, UB at D, UB at E plus UB at F. So that is BA, that is KQ by, one is positive charge, both are negative charges separated by distance. If this is L, this is L, it is a equilateral triangle, this is also L. KQ square by L square. Potential energy at B due to the charge present at C. Here plus Q so minus Q plus Q, that is also KQ square by L square. Potential at B due to D, here minus plus Q to get a BD. So for BD is root 3 L, because it is L separated by 120 degrees. By using cosine rule, we can get dB, which is root 3L. So this is minus Q plus Q minus KQ square by root 3L square. Potential at B due to D over potential at B due to U, that is also root 3L. But minus plus here minus kq square by 3l square. Potential at B due to F that is also here plus minus q. So you'll have kq square by 3l square. So at here 3l, here root 3l, here also root 3l. So this will be minus 1 is plus minus plus again minus, so get cancelled out. So then you have a 3k 6k 5k q square by 3l square. Similarly, if you find at E, that is also same as UB. So third option, similarly, we can say potential at C and F also equal. You calculate in